Hello, I'll start the second week team project from now on. Our building is Lotte Tower. Here are 5 members of our team. Let me tell you the table of contents first. First, let me tell you about the background of the building, and another member will talk about the design and structure of the building and notable issues. First, the background of the building. Let me tell you why we chose Lotte Tower. Lotte Tower is the 50th tallest building in the world and the tallest building in Korea. And I thought I could study many construction skills as a skyscraper. Next is the basic information of the building. The building is located in Songpagu, Seoul and was built for a total of 6 years. And it is designed by Kohn Pedersen Fox. Next, I'll talk about the project organization. This table shows who the owner and the manager are and which companies are responsible for plan, complex, supervision, and construction under them. Let me tell you about the floor organization. First, if you look from downstairs up to the 12th floor, there is a lobby and complex service space, and above that, there is an office. From the 42nd floor, there is an office there, and above it is a hotel and private office. The last section consists of an observatory. So, Lotte Tower has 123 floors and 6 floors underground. Next, I'll talk about the history of Lotte Tower. First, let me tell you the history of building permit. First, in 1987, Lotte will purchase the site of Jamsil in Songpagu, Seoul. However, construction failed in 1994 due to runway problems at Seoul Airport. Then, in 1998, Songpagu office granted a 36-story building permit. But in 2002, the Ministry of National Defense opposed the construction of the 112th floor. Finally, in 2006, the Seoul Metropolitan Government approved the construction of 555 meters, and in 2010, Songpagu authorized the construction. And this is about the construction process after the final permit. First, we will start the mat foundation in 2011 and start the construction of the frame in earnest in 2012. Next year, install the outrigger and belt truss. In 2014, it will surpass 305 meters and 410 meters in 2015. Eventually, in late 2015, the topping out ceremony will be completed in 2016 with the last beam raised to 123 stories. So I talk about the history of Lotte Tower's permit process to completion after construction process. And this shows the response of the users. Most reviews about Lotte Tower in Naver or Google are about Seoul sky. So we learned about the background of Lotte Tower.
This is Intang, and from now on, let me tell you about design issues. First, Lotte Tower's appearance is motivated by the shape of pottery and brush. So, to express the soft line and 2 lines of notch section, a lot of curtain walls are used. John Gustafsson, president of Curtain Wall Consulting, said that He had worked on many curtain walls, but nothing was as difficult as Lotte Tower in terms of shape. The curtain wall has 12 mm of argon gas, 8 mm of tempered glass, and low weight coating, which makes it strong and keep the energy inside. And there are 21,000 units that weigh as much as 600 kilograms. What's more surprising is that 17,000 of these shapes are all different. As you can see in the picture, as the building is sloping upwards, all the points of the unit are marked on the entire floor of the slope section depending on the weight, width, and corner angle of the unit, which requires a high level of precision construction. And another design issue is wind resistance design. Lotte World Tower was designed to withstand wind speeds of 128 meters per second. A series of wind tunnel tests were conducted, and the results were reflected in the structure design. According to research paper, after 50% schematic design stage, a high-frequency force balance test was conducted, and the analysis was done twice at the end of the design development and after the 60% DD stage. During the 90% DD stage, when most of the dynamic properties were identified, an additional aeroelastic model wind tunnel study was conducted after 50% ST stage and after the 90% DD stage, respectively. The wind load calculated by the aeroelastic model showed approximately 17 to 22% lower than that by the HFFB. Base shears also came out about 8% below the HFFB. In the expert's view, the aeroelastic model study is a more preferred process. So, as a result, Lotte World Tower is satisfied with its acceleration limit and torsional velocity limit.
Alright, hello, I'm Hyunmin Choi, and now I'm going to talk about constructional analysis of Lotte Wall Tower. Here is contents. I'm going to explain these parts in this section, okay? Before starting foundation construction process of Lotte Wall Tower, subsurface explorations was carried out. And then ground improvement work were carried out. Constructional team dig under 38-meter and carried out ground improvement work by driving 108 PRD piles that has 1 meter of diameter onto these bedrocks. And these cast-in-place piles has 60 megapascal strength. The main purpose of this work was to prevent subsidence of foundation and to reduce unequal settlement rate. After ground improvement work, foundation process was carried out. In Lotte Wall Tower, mat foundation was applied. Before talking about Lotte Wall Tower's case, I will explain about mat foundation. Mat foundation is footing which has continuous thick concrete slab on the soil that extends the entire footprint of the building and increases the soil bearing capacity power. Since it can support the entire building loads and safely transfer it to the ground, it is suitable for heavy building construction or ground that has low bearing capacity. And main advantage to this method is that it is a stable foundation to unequal settlement. This is an introduction of mat foundation that applied in Lotte Wall Tower. Its scale is 32,000 cubic meters and its casting time was about 30 hours. Consecutive concrete casting was applied during the casting process, and especially ultra-low heat concrete was used, which has 50 megapascal of strength, and lastly, large high-tension deformed bars were used. In this process, mainly four methods were applied. First of all, precision analysis of ground, and secondly, cut-off wall, design of ultra-low heat concrete, and lastly, application of high tension deformed bars. First of all, before foundation construction, precision analysis of ground was taking place. Especially, this process was really important because Lotte Wall Tower is high-rise building, and therefore the result of these analysis can affect subsequent process such as selection of ground improvement method and foundation method, etc. In this process, these four analysis methods were carried out. Firstly, core sampling analysis was taking place so that construction team could know the physical features of the ground. And secondly, phase mapping process was carried out. The purpose of the phase mapping is to evaluate the surface of site's bedrocks. And this mapping process was collaborative work with Korean teams and foreign experts. And third, resistivity exploration was carried out so that construction team could assume possibility of endurance decreasing factors of RC concrete foundation. And lastly, plate bearing tests that can measure the endurance of bedrock was carried out. Data obtained from these methods were applied in foundation process. And second main process of mat foundation was inserting cut-off wall around the Lotte Wall tower site. Cut-off wall means a wall surrounding excavation site or foundation used to exclude groundwater from sites. This cut-off wall can be made of various ways such as steel sheet piling or concrete diaphragm walls and so on. In this case, concrete cut-off walls around Lotte Wall Tower site were inserted into bedrock to eliminate any possible infiltration of groundwater. These walls have 27 meters of depth and 1 meters of thickness. This is a short video of cut-off wall that's surrounding the building. As you can see, these walls surround the entire buildings to keep buildings safe from the ground, like this. And third main process of mat foundation was mixing design of ultra-low heat concrete. Since Lotte Wall Tower was high-rise building that with tremendous scale, consecutive concrete casting was needed. Not only that, in this mass concrete work, one of concrete's chemical reaction called hydration reaction can cause thermal cracking, which can induce lowering of concrete performance. So there were rigid requirements for mass concrete in the foundation, like this. To satisfy these requirements, Lotte ENC and Asia Cement collaborated, and after 2 years of collaboration work, special ultra-low heat cement mix was invented. According to experiment of hydration temperature measurement, the concrete using this cement that fulfilled design strength 50 megapascal had 50% lower maximum temperature compared to normal concrete and fulfilled other design requirements like this. So this special ultra low heat cement was used entire mat foundation process. And finally, construction team used super high tension deformed bar in mat foundation. If we sort deformed bars by yield strength value, there are mainly three types of bars like this: HD, SHD, UHD. Among these bars, SHD bars that has 51 millimeter diameters were used. So construction teams located SHD bars on site, and they coupled each located bars into BMS bar, the mechanical coupling method of steel bars. An entire weight of bars was 4,200 tons. And thanks to these methods application, met foundation of Lotte Wall Tower was successfully constructed. And it has roughly 1.8 times thicker than that of Burj Khalifa and 80,000 tons of high-strength concrete that is more than 2.5 times the amount of Burj Khalifa. From now on, I'm going to talk about statistical system, a structural system of Lotte Wall Tower. There are mainly two systems like this, gravity resistance system and lateral force resistance system. And although these systems are working together and cannot take each forces separately, these systems can be assorted as specializer for each forces. So there are core walls and mega columns that specialize in gravity resistance, and outrigger and belt trusses that specialize in lateral force resistance. First, let's talk about gravity resistance system. As I mentioned, there are core walls and 8 mega columns that has RC structure. This is a picture of those systems, and this is a table that shows weight of each system's member. When we see this structure in cross-section, you can see that these system members have different thickness in different floors. You can tell that when it goes upper side of building, thickness of gravity resistance materials are getting narrower. And since these are RC structures, they have between 40 and 80 megapascal of strength. Usually concrete that has more than 40 megapascal strength is called high strength concrete. But when you build building that use this kind of concrete, prevention for spalling failures should be considered. Spalling failure is the process of surface failure in which flakes of concrete are broken off in fire accident like this because of internal water of concrete. For high-strength concrete, spalling failures can happen easily due to its dense structure. The main problem of this phenomenon is that structural performance of concrete gets lower and cause ultimate failure, which means collapse of entire buildings. In Lotte Wall Tower case, these polymix fibers were added to concrete so that can prevent spalling failure by making tiny gaps that acts like exit of these water vapor. And this is an explanation of work of gravity resistance system. Lotte Wall Tower's gravity resistance system is consisted of core walls that are located in the center of up to 123rd floors, and 8 mega columns are located around the perimeter of building like this, and deck slabs with steel beams. These members are connected to each other and can disperse gravity loads effectively. In fact, core walls support 60% of building loads and mega columns support 40% of building loads. Okay, this is the end of my part. Thanks to listening and watching.
As mentioned by Hyunmin, according to design intent, lateral loads on the building are resisted by the RC core walls, mega columns, arm riggers, and belt trusses. Among them, I'm going to tell you about lateral load resisting system applied in the building, arm rigger, and belt truss. Arm rigger systems function by tying together two structural systems, typically a core system and a perimeter system. An arm rigger system engages perimeter columns to efficiently reduce building deformations from overturning moments and the resulting lateral displacements at upper floors. Installing belt truss, not only the columns which are located at the end of arm rigger, but also other columns can function as constraining arm riggers. Also, belt trusses and arm rigger trusses are made of steel. During the SD phase, it was originally planned to have 3 sets of arm riggers and 6 sets of belt trusses. During DD phase, a comparative study of the lateral load resistance ratios of the outrigger belt trusses and RC cover was conducted. As a result of the study, the two sets of outriggers and the two sets of belt trusses were identified as the most optimal solutions for the lateral load resisting system. It was found to be inefficient to have many sets of outriggers and belt trusses in the system, so the plan was changed. Two sets of outriggers are installed at the 39th to 41st floors and the 72nd to 76th floors. The contribution of outriggers to control other lateral displacement is 28.5%. And steel box B2, like this one, is used for outrigger diagonal members. Since they mainly support axial loads, the web thickness of the steel box was increased to 80 mm, and the flange thickness was decreased to 20 mm. The top chord of the outrigger penetrates the RC core wall and reaches horizontal truss member on the other side, so that horizontal forces in the RC core walls can be easily transferred to the outrigger trusses. For the design of the connections between the outrigger members and the mega columns, it was intended that an outrigger diagonal member and a horizontal member be connected at a column-embedded connecting post. Horizontal forces to the outrigger diagonal member are supported by the bottom chord, and the top chord supports vertical forces to the diagonal member. And next is about belt truss. The two sets of belt trusses are placed at these floors, of which height is equal to 3 or 4 stories. The upper belt trusses supported the uppermost lantern structures, and the lower belt trusses support the hotel columns, and it was proved that the belt truss is more effective than the outrigger truss at that location. The upper chords and the bottom chords of the belt trusses at the 104th floor are steel boxes of B2, this one. And it is about connection of belt truss. If the belt trusses supporting the hotel columns are installed along the outside of the mega columns, the mega columns can be constructed continuously regardless of the belt truss construction process. So the belt trusses are fabricated through the field welding of pre-assembled trusses with the embedded plates on the outsides of the mega columns. To reduce deformation of the 14.4 meter high embedded plates caused by axial loads, and to design proper dowel bars, short transfer bearing plates are needed in every space between dowels. The embedded plate is installed on only one side of the mega column, but in some floor levels, the plate would enclose all 4 sides of the mega column. And we will study more about connection of outrigger and belt truss, and also about spandrel girder next week. The important members such as spandrel girders, belt trusses, and hotel steel columns have redundancies to avoid a sudden collapse when one of these members loses its capacity in case of fire or unexpected impact. It is designed such that the loss of any members does not result in disproportionate collapse of the surrounding structure.
Hello, I'm Jae-seok Choi. I would like to talk about notable issues. I searched for in 3 categories. First is traffic congestion. Jamsil, where Lotte World Tower is located, is one of the city's major traffic arteries, and people are experiencing inconvenience due to heavy traffic. Lotte has invested about 526 billion won, that's 20% of construction cost, in the transportation improvement project. I searched what is included in that project. First is underground fast transit center. It reduces traffic congestion caused by metropolitan buses changing lanes and stopping for passengers and make public transport more convenient to use. Second is underground roadway at Jamsil Gil. It will be constructed at Jamsil Low, and the ground level will be used for pedestrians and bicycles for easy access to Sokchon Lake. Third is underground pedestrian square at Jamsil intersection. It improves convenience for public transport. Fourth is entry and exit lamps at Jamsil public parking lot. It facilitates traffic flow to Olympic Expressway. Fifth is tangential road expansion. Lotte donated costs for the Tanyeoncheon expansion project planned. 6 is passed to subway line number 8. It improves access and makes public transport more convenient to use. 7 is underground bicycle parking stands. It facilitates the use of public transport and reduces car traffic. The last is transportation system management. It improves the geometric structure and lane operation plan for 33 intersection and connecting roads. Next is safety issues. It was confirmed that Lotte World Tower had several safety issues during construction, and those issues were concerned as the second collapse of Samsung department store. Samsung department store collapse was a structural failure because of poor construction and over-construction. The collapse of the building was actually predictable. In April, cracks began the ceiling of the restaurant. From May, sand began to fall from the crack, and the bottom of the 5th floor began to sink slowly. These cracks also occurred during the construction of Lotte World Tower. First is cracks in mega columns. In February 2013, the site inspection revealed that the cracks in the mega columns of Lotte World Tower were caused by welding heat. Second is cracks on the floor of Seoul 3080. In fact, as shown in the image, cracks occurred in the cement mortar and epoxy coating during the contraction process, and there are no cracks in the slab. Third is cracks on the ceiling of the avenue. Cracks on the ceiling of avenue were not found in the concrete part of structure, but occurred on the joint of area of the fire resistance board. The last is cracks in the parking lot. The cracks occurred on the surface of the concrete and finished materials due to contraction caused by aridity and change in the temperature. The cracks are fully repairable, including negative moment. Next is suction lake issues. In 2013, it was rumored that the water level in the suction lake had dropped by 1 meter, while some 400 tons of water were discharged every day at the construction site of Lotte World Tower. But 27 meters deep and 1 meter thick concrete shielding walls were inserted in the lock at a diameter of 1.5 kilometers to block underground water from entering the site. In 2014, a sinkhole phenomenon was discovered on the road around Lotte World. Sinkhole near Suction Lake turned out that they were mainly caused by the subway line number 9 construction work, and it had nothing to do with Suction Lake.
This is our law. Every member in our team did researching, making PPT and presentation. I was in charge of outrigger and belt truss. Youngjun was in charge of general building information. Hyunmin researched about foundation, core wall, and mega column. Jae-seok took charge of notable issues, and In-chang was in charge of design issue. And this is our weekly study plan. This week we researched about general building information and foundation, and next and third week we'll focus on structure, connection of outrigger and belt truss, spandrel girder, and diagrade. And during next 5 weeks, we'll study about construction, ACS construction method of pumping concrete, auto sliding system, and then about skin, BIM, disaster prevention system, sustainability will be studied. And how do we study about it? First, we will research and study about structure and construction method that is applied in Lotte World Tower, and we are going to study more deeply by comparing with other buildings and construction methods. We hope that we can study in more detail by comparing and can know why that method is applied in Lotte World Tower. Thank you for listening to our long presentation. Thank you. Thank you for listening to our long presentation.